Hello everyone, my name is Vishwajeet and today I am going to explain the project that I had done. The topic of this project was tall building design, which was done as a part of an online course from Skyfi Labs. So first of all, let us see the problem statement. In the problem statement, here you can see this is the building that has to be designed or analyzed on the ETABS software. In the problem statement it is mentioned that this building is a 23-story building, but the each floor or group of floors don't have the same plan. Here you can see, so basically they have divided the building into four type of groups. We may say four groups which have different story patterns or plans. So from story 1 to 8 the building is having a plan like this. In the 3D view also you can see it. Also from story 9 to 14 it is different, similarly different for all the other stories. Also it has been mentioned to use the following sections of beams and columns. In the column they have been given us three sections, and similarly in the beam they have given us three sections, and they have asked us to auto select between them. So basically we need to define all these beam and column sections and then tell the software to auto select between them. Also it has been mentioned to use the M40 grade of concrete and rebar material of HYSD 500 and a mild steel of 250. This is for longitudinal sections, as this should be used as longitudinal reinforcement, and this as tie bars or stirrups. Also it is mentioned to use slab of 150 mm thickness with M40 grade of concrete. So it is given to use auto draw cladding. So auto draw cladding is basically the walls. The walls should be auto drawn, that we will see in the software how it is drawn. And also a cladding load of 0.2 kN per meter should act through these walls, so that also we will learn. It is given also to apply the wind load considering the parameters of Bangalore region. Okay, and on each floor or the slab is carrying a dead load of 2 kN per meter square for each story. Also live load is varying in each case, so we will see how to apply this live load for each group of story. Okay, so let us go in the ETABS software. So this is the project that I had done as part of the assignment. So this is a 23-story building. You can see over here there are 23 stories in this. Okay, and so first what I had done is I had defined the material properties. The material properties were M40 grade of concrete, steel of HYSD 500 and mild steel of 250. Then what I had done is I had defined the section properties, that is the section properties for beam and column. The beam of 500 by 300 cross section, and similarly other two, and column other three. Then after that I had added a new property of beam auto select to tell the software to select between these three automatically as required by them, and similarly for the column section. Now the next part that we have to define is the slab section. So in the problem statement it was given to define a slab section of 150, so I had defined the slab section of 150 mm thickness. Next so we have defined the frame sections and the slab sections. So what we have to do next is we have to just draw the columns, beams and the slab sections. So I have already drawn them. Here you can see this is the story number 5, fifth floor plan according to the given problem statement, and this is the 3D view. So I had drawn all these beams and columns and the slab sections accordingly as required. Then what we can do is we may draw the claddings or the walls by the auto draw cladding option. This option is not visible right now because I had already run the analysis and I need to just unlock this. Okay, yeah, auto draw cladding option will be enabled now. So this will draw the walls or claddings to the structure. So now we will assign the loads. There are three types of load that had to be assigned: dead load, live load, and wind load. So dead load, live load, and wind load can be assigned by selecting the particular frames or shells for the members to which they need to be assigned. If you are selecting a shell, select the shell loads and select the uniform and apply the loads like dead load and live load. Now similarly to the beams we need to apply the cladding load of 0.2 kilonewton per meter as dead load and only to the outer section because the walls are only at the outer section of the structure. Okay, next, so now we will define the wind loads. To do that, go in the load patterns option and here you need to add a new load with name wind and wind load type wind and selecting the auto lateral load as Indian IS 875. So in this, here in the properties you can see there is wind speed, terrain category and all. So this is obtained from the IS 1893 wind load book or code. Similarly, now you need to assign this load to the vertical walls or the claddings. So first for that you need to select these walls and then assign shell load and wind pressure coefficient. So here you can see windward side and leeward side or sides. So windward side is the side which is directly 0 degree with the wind direction, and leeward side is opposite to that, and similarly sides, these are the two opposite sides. The coefficient may be obtained from the IS code for all these sides individually. So this is how we have applied the dead load, live load and the wind load. After doing all this, now we need to analyze the structure. To do that, just select run analysis of the model. The software will run the analysis for the building. This may take some time. Yeah, the analysis is over and you may see the displacements due to the dead load case in the 3D view. So if you go on any point, you may see its displacement at that point. After doing this, we may design the structure. To do that, just go into start design check. Again the software will do the design check. This will take some time. Yeah, it is showing that the analysis and section differs for 7. Do you want to reiterate? So if you want, you may do it, or there is no need right now. Yeah, so here you can see the reinforcement details for each beam and column is given. Just right click on any section. This is the beam number 5 of story number 23. So you may see the details of that section, which is 500 cross 300 beam section, and reinforcement details and the load, that is forces that are on this beam and design moments, and the rebar that is required. Similarly, rebar that is required for shear force and torsion force. Also, you can generate a summary report of the project. For that, just go into the report section and double click on the summary report. Yeah, this is the summary report. So thank you.